the semester. So I guess a couple of weeks later we will have midterm exam. Not sure. But anyway, middle of the semester. It's approaching the middle of the semester. It will cover up to the chapter 6 or chapter 7. Pretty much is chapter 6. And also please, you need to start to work for the project for undergraduate student. Project 1 is still required, but once you complete the second project will be optional, it's extra point. So, however, for graduate student, both project 1 and project 2 are the mandatory, so you better start right now. There's no extension, do not expect any extension or excuse of the project 2. Okay, so today we are going to talk about the threat. So GA need a little bit more time to do the exercise lab. Today we are going to have the exercise lab for Unix programming using the compute engine that you created. Please try to be familiar with your compute engine. The more time you mess up, the better experience you will get. So please try to use your the compute engine. And also, even though you do not never use the GCC compiler, which means the C or the C++ programming, so I believe that you can understand the meaning of the code and the compilation, and it doesn't require any deep programming skill as long as you are able to use the existing system library. Sometimes you need to check the detailed manual or the documentation to use the specific the system library. I mean the system code or system function. Then as long as you can compile such a program, it will be totally fine. Okay, so please start to work for the project to implement the personal Unix shell program. So today we are going to continue to discuss about the thread. To speed up, today I'm going to use the slide because I think pretty much I explained the basic concept of the thread the last time. So I'm going to use this slide for the discussion. So the last few weeks we spent a lot of time to discuss about the process. What is a process and how to create the process, how to manage the process, and so there are several issues that we discussed regarding to the process management. Then that's the thing, I think the data structure that consumes a lot of computing resource. So that is the process. So process need memory, and the process will be executed by the CPU computation. So it needs both the CPU and the memory space. That's the most important resource on your computer. So that's the critical how, depending on how to manage the computing resource used by the process. So that is critical on the process, your computing performance. So many of the operating system and even the architect who designed the computer, they spend a lot of time, they put a lot of effort to reduce to increase the performance, to reduce any overhead of the process management. So thread is one of the way. So last class we talked about what is the thread. Thread is the kind of sequence of the instruction. That's true. It is not possible to execute the two instructions at the same time, unless you have the dual core or the dual multiple CPU. So suppose that we have the single core, single processor, the single CPU, then only one instruction at a time, okay? Which means any program will be executed by running the sequence of instruction. However, if we see our application programs such as Chrome or MS Word, for example, MS Word, while you are typing, sometimes you can see the underline misspelled. So there might be spelling checker. Also, there's a rendering program that design and manage the format of your Word file. If that is out of the range, then it will be the wrapping the text and adjust align. So several the functions are running simultaneously. That doesn't mean the several instructions will be executed exactly the same time, but the several different sequence of instruction will be running. That is the idea of thread. Because even though there's a spelling checker, input, and the rendering and the other functionality, they are in the same program, MS Word. Okay. In case of Chrome, when you run the Chrome, it will create a different process, but it's from the same process, same program. So what if we share as much the information as possible? If we can share the information instead of instead of using the memory, why don't we share? That is the idea of the thread. So is there any the possibility to share such information? For example, in other words, when we design such several different from the one process, when we have the one process, especially the text area, this program, and we have the data, and we have a stack for temporary information, and here the dynamically allocate the information. So from the process point of view, if we share divide some of the sequence of the instruction, which part can be shared, which cannot be shared. Okay. So for example, the stack is the what? It's a temporary space. For example, when we have the full loop like this one, local variable will be allocated here, because when you out of this loop, it will not be used. It's the same temporary space. So this kind of temporary space cannot be shared because it's temporary. So each thread, the separate the data structure of the process should manage such a stack point, stack area. Okay. Another one is a register. Register means this is a memory, this is the CPU, so this is our computer. CPU need the specific instruction. Okay. How does the CPU recognize location of the instruction? Using program counter. Okay, so it's called the PC. Where is the PC stored? Is the somewhere memory? Processor. Processor specifically where? So register. Register is the top of the storage pyramid. Do you remember the triangular shape? So top of that is a fast but small. The bottom slow but it's a cheap and very big. So what is the top of the storage pyramid? It's a register. Register is the storage. So if you remember, why don't you recall the experience on assembly? So like the move is one of the popular. Move instruction is what? Transfer the data from where to where? Memory to memory. That's one possibility. And also move memory to register. Then also register to memory. These are the moves, because a lot of time we read the data, write the data, change the data using the move. At the time the register is the storage. So while you are running the sequence of instruction, in other words, executing the program, this register information will be changed, whatever. Then at certain time we have the context switch. What is a context switch? So one of the questions in your quiz, not context switch, context switch. This is a CPU time. Let's say this is a CPU time. The one program uses the CPU time. Even though we have the fancy, nice, really the innovative idea to manage the CPU, but we cannot increase the CPU time. No way. Okay? We cannot shrink the CPU time. as if we cannot control the lifetime. So, but how we can maximize such as utilization? So we try to use as much as possible. To do that, we slice, we chop the CPU time, and this one is used for the process 1, next one is process 2. So at this moment, we need to switch, okay, the process, one process to another process. During that switching time, all information on the CPU register should be replaced. Okay, you need to save this information from P1 to where? PCB. Do you remember that PCB is the process control block? It's the data structure keep all the information about CPU. So, the process. So PCB, P1, this is the PCB for 1. Then this information will be stored. And the P2, also PCB2 has the PCB, and this will be loaded into the register. Then continue to process the instruction. At this time, so register is if you are running, so instead of P1, if we are talking about thread 1, thread 2. So this part is thread 1, this part is thread 2. Then while we are running the thread 1 instruction, their register information will be different from another thread. Okay, so we need to keep such a register information separately. We cannot share. And we consider each thread is the part of instruction, sequence of instruction. It looks like a process. So we can schedule. We will discuss a little bit about such a thread scheduling later. We need to schedule. For example, when we have the 4 threads in one process, 4 threads should be scheduled. Which one will be first? Because anyway, each thread has a sequence of instruction. We cannot run at the same time, 2 threads. So we need to schedule. So scheduling information. And any signal for the communication between thread and between thread and the process. So also definitely thread specific data. All this information are independent from other thread. Otherwise, on the other hand, the other information can be shared, like the instruction itself and the global data and other information can be shared. So, as much as possible, we can share the data structure to save the memory resource and to save other resources. That is the thread. So in terms of the PCB, why? Because the PCB keeps all the information about the process. So like the process pointer and the process state, the process number, these are the identical for each process. So we can share. However, the program counter like the PC and the register information, this kind of information, thread specific information, we can create only this part. All the other, the data structure, we will share. So that is the idea of the thread. At that time, sometimes when you read the operating system book or some technical paper or white paper, you will see the heavyweight or lightweight process. It's exactly same meaning as the lightweight is the thread. It's a light version of process, lightweight process. And on the other hand, the heavyweight is the entire process, including number of threads created by this process. So you don't have to confuse. When you see the heavyweight, that means it's the normal process, including all the thread. And when you see the lightweight, it's the thread that you know. Okay. So these are the example of that, like the different program counter and register. But in one PCB, we create the number of such a thread specific information on PCB. So at this time, depending on, it's not a critical, but some of the operating system create the one PCB per process that manage a number of thread specific information. On the other hand, so we will see the different types of thread later. So user specific, mostly they will manage in such a way. However, there's another type of thread. Even kernel use kernel thread. Kernel use the thread. So if you are very good at to catch the small or the very quick information that I showed you before using the compute engine, when I show you display the list of a process, there are a lot of K thread. So these are the kernel thread. Sometimes the computer operating system need to work for the kernel. So do you remember that there are viewer mode, user mode, and kernel mode? During the kernel mode, your operating system should work on behalf of user requests, like the writing the file, writing the data, or read the data, connection, and so on. So at that time, the kernel thread actually work for that request. So even the operating system kernel work. So for that, the management, they manage the different thread specific PCB. Okay. So these are the very high level diagram. This is a memory. In the memory, so we have the one piece, the OS, the kernel, the OS, the manage the PCB information. Then it has the two threads you can create. Benefit, from now on we are going to discuss about such a benefit. So like for example, if we have the two threads for one process, we can assign each thread to the specific CPU or the core. Then it will be run simultaneously. So if you already took the parallel programming class, or if you are interested in the parallel programming or the distributed programming, so most of the time, the beginning of such a class, you will learn how to design, how to change your program. Okay, make the module by module. Then each module will be executed by the specific core or specific the processor. At that time, we can use the thread. So if you are running the same module but multiple, so you can create a number of the thread and assign to the specific core. Yes?
Is it possible to have a process without a thread?
Process?
Without a thread?
So his question is it possible to process without thread? It depends. On what definition? So if we consider the one process as a thread, at least one thread, right? Because the process itself is also a thread. Okay? But if you define the thread as a part of the instruction process, then the one process does not have the thread until create the thread. Okay? So because depending on some of the textbook use the thread instead of process. Okay? So because of that, but most of them define the process is the data structure that you create, but the process can create the thread. So at the time, sometimes you may not use the thread, but it depends on how you define the thread. Okay. Okay. So this is a multi-threaded programming. So nowadays the two-speed. So we are using a lot of such a multi-threaded programming, whether or not you realize. So that means there are two types. User can create your own thread, or operating system also use the thread. At the time you don't realize whether you are using the thread. But this is nowadays very popular to maximize the research. Okay. So one of the example of such a thread is the POSIX thread. So we have seen the POSIX, the system library. Okay, Unix or the Linux system uses such a POSIX. Actually, POSIX is a kind of not implementation. It is a specification. So POSIX thread actually define this is the thread. Then there are many versions of the thread implementation. Thread library that follow the POSIX, the specification. It's kind of standard used in Unix and Linux system. So one of the example is the pthread. You heard about the probably if you did